Okay, lesson 3 started. So we have f of x is 3x squared plus 5 all over 2 root x. So first thing to do is rewrite the bottom. It's 2x to the half. Split up the fraction, so 3x squared over 2x to the half plus 5 over 2x to the half, and then rewrite each term. So 3 over 2, take with the powers and dividing, so 2 take away half is 3 over 2, and here 5 over 2 is the number, and for no x's, take away power over half, so it's x to the minus a half. So then to differentiate it, remember times by the power, so differentiate that, 3 over 2 times 3 over 2 is 9 over 4, take away 1 to the power, so a half, and this one, 5 over 2 times a half, minus 5 over 4, take away 1 to the power, is minus 3 over 2, and integrate the original, so add 1 to the power, so 5 over 2, so it's 3 over 2 over 5 over 2, x to the 5 over 2, add 1 to the power to get half, so plus 5 over 2 divided by a half, x to the half plus c. Then simplify the fractions, so here the halves just cancel out, it's like a 3 over 5, x to the 5 over 2, plus here the halves cancel out, so 5x to the half plus c. Okay. Remember, it's always important to simplify first, otherwise we can't differentiate. Well, unless you want to use the quotient rule. Quotient rule is what you do in this lesson anyway. Second one, we have f of x is x squared at 3. We have g of x is 4x squared at 12. So hopefully you should be able to spot without too much issue that g of x is just 4 lots of f of x and one transformation. You can do it in more than one transformation, but the question says a single transformation. So therefore, it's a stretch in the y direction, because it's outside, so it's y, and the 4 stays the same as the scale factor 4. Okay. Third one, we're solving 5e to the x add 5 equals 3. Well, this point here, I could turn everything to e, so I could, one option, I could do e ln 5 times e x plus 5 equals e ln 3, add the powers, cancel out the e's, and get an answer that way. Yeah, so x will just equal ln 3, take away ln 5, take away 3. Yeah, or another way is just since there's 1x, I can just do inverse functions. So divide by 5 to both sides, do ln on both sides, so that ln and e cancel out, so x at 5 is ln 3 over 5, and then take away 5, which I just realised that should be 5 there as well. Take away 5, so x equals ln 3 over 5 minus 5. That's into these brackets, it's okay to put minus 5 there. Normally, I'd write it like that, wouldn't I? Good. I'm going to make a video about this point here, about when to use ln's, when to use e's, when they cancel, when they don't. Okay, next one. We've got the first 3 terms of geometric sequence. So we have x, add 1, x minus 1, 2k, sorry, the k is not x's, 2k minus 5. And we know it's a geometric sequence, so that means ratios are equal. So to get this ratio, I do k minus 1 divided by k plus 1. To get this ratio, I do 2k minus 5 divided by k minus 1. Since it's geometric, the ratios are equal, so it times up. Do crisscross, whatever you call it. Expand, so k squared minus 2k plus 1 is 2k squared minus 5k plus 2k, so it's minus 3k, minus 5, take everything to one side, so k squared minus k minus 6, solve that, so k minus 3, k plus 2, so k is 3, or k is minus 2, and it says find the sum to infinity of the sequence. Okay, well the sum to infinity means that the common ratio has to be between minus 1 and 1. So let's look at what the sequence look like if k was 3. I would have 4, because 3 had 1, 3 take away 1 is 2, 2 times 3, 6, take away 5 is 1. So here look, with the sequence if k was 3, a would equal 4, r would equal a half. So the sum to infinity using the formula a over 1 minus r would give me 8. Okay, let's double check what would happen if k was minus 2. So sub it into there, minus 2 and 1 is minus 1, minus 2 minus 1 is minus 3, minus 2 times 2 is minus 4, minus 5 is minus 9. So this one, r is 3. Now that's not between minus 1 and 1, so the sum to infinity will diverge, it will go off to minus infinity. So k must have been 3. So that is minus and minus is 8. And the last one, mechanics one. So we have a particle of mass 5 kilograms is placed on a smooth slope. So there's that slope. Angles 30 degrees to the horizontal, and our particle is mass 5 kilograms. Smooth, so I don't have to worry about friction. So the force is straight away. I need the weight going down, so 5g go down, and normal going perpendicular. Now it's going to go down the slope, so acceleration is going to go that way. And it says there's no external forces, there's no force pushing it, there's no forces pulling it. That's all there is. So we need to change the weight into horizontal and vertical. Because remember, with these questions, we tilt a page to make it horizontal and vertical. So this angle here is 30. Here's my adjacent, so it's 5g cos 30. This one's 5g sine 30. And now I want the acceleration, so I'm going to do F equals ma in that direction. So I've got my force going down was 5g sine 30, so that must equal the mass, so 5 times a. Well, the 5's cancelled out, so g sine 30 is a, and sine 30 is just a half, so I get half g equals a, or if you type in the calculator, 4.9 meters per second squared.